We are on page 169, lesson 85. Use and make line plots. A line plot uses marks to record each piece of data about a number line. Louise measured the heights of the tomato plants in her garden. She recorded the height of each plant. How many tomato plants are here? Each X stands for one plant. Count all the X's. So if we look over here, it says height of tomato plants in inches. So under here, we have 11 inches, 12 inches, 13 inches, 14 inches, 15 inches. Each one of these X's stands for one plant. So there are 1, 2, 3, 4, 5, 6 tomato plants that are 11 inches high. 1, 2, 3, 4, 5 plants that are 12 inches high. 1, 2, 3, 4 inches, 4 plants that are 13 inches. 1, 2, 3 plants that are 14 inches, and 1 plant that is 15 inches. They're asking us to count all the X's. Each X equals one plant. So we're going to count all of them regardless of their height. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Count all the X's. There are 19 in all. This tells the total number of plants. How many plants are taller than 13 inches? So the 14 and the 15 would both be taller. We count the X's. 1, 2, 3, 4. Add the number of X's for 14 and 15. 3 plants are 14 inches tall. 1 plant is 15 inches tall. 3 plus 1 equals 4, so 4 plants are taller than 13 inches. Use the spelling test scores for a line plot for 1 through 3. So let's take a look over here. We have our spelling test scores. Some students scored 85, some students scored 90, some students scored 95, and some students scored 100. So let's see how many students scored 85, because that looks like it has the most X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 students scored 85. For 90, we have 1, 2, 3, 4, 5, 6, 7, 8. For 95, we have 1, 2, 3, 4, 5, 6. 6 students scored 95. And we have 1, 2, 3, 4. 4 students scored 100. Which test score did most students receive? Now they're not asking how many students, they want to know the scores. The scores are down here. Since there are the most X's for 85, that is the score most students received. How many more students scored 90 than 100? Here's that how many more. So we're not bringing together numbers. We're finding the difference between the 90 and the 100. So over here, the 90 was 8 students. 100 was 4 students. We're not saying 8 plus 4 because that would give us the total or the combined. We want to know how many more X's are there for the 90 than the 100. So our how many more here means to subtract. 8 minus 4 equals 4. How many students in all took the spelling test? Here is our in all. Now we're going to be combining all of these numbers together. When we're bringing them together, our number is getting bigger. So we think about adding. I have 4 numbers here to add. I have a 10, an 8, a 6, and a 4. Automatically, I think 6 plus 4 equals 10. I'm going to add those 2 numbers together to get my 10. I already have a 10 up here, so I can take the 10 from my 6 plus 4 and add it to the 10 that I have from the students that scored 85, and already my total is 20. So far I've added the 10 from the 85, and I added the 6 and the 4 from the 95 and the 100, which I've got a total of 20. Am I done? No, I still did not add in the students that scored 90, which was 8. So 20 plus 8 equals 28. 28 students took the test in all. Okay, we're going to be on page 170. Use and make line plots. I have a secret. Line plots are my favorite. So this is, I hope, going to be as much fun for you as it is for me. Use the data in the table to make a line plot. The title over here says, how many shirts were sold at each price? Here are prices, and here are the numbers sold. So there's $11, $12, $13, $14, $15, $16. Okay, for $11, 1 shirt was sold. So under here I have all of the prices that match what was in the table. And for each shirt that's sold, I'm going to place an X on top of it. So for 11, 1 shirt was sold. On top of the 11, I'm going to place an X. Next, I see 12. I come over here. 4 shirts were sold for $12. I'm going to put 1, 2, 3, 4 X's. $13. How many shirts were sold? 6. 1, 2, 3, 4, 5, 6. Okay, so far I have 1 shirt for $11, 1, 2, 3, 4 shirts for $12, and 1, 2, 3, 4, 5, 6 shirts for $13. I'd like you to fill in the X's for $14, $15, and $16. Now, how many shirts were sold for $12? If we look here, we count 1, 2, 3, 4. 4 shirts. At which price were the most shirts sold? So when you finish your line plot here, you're going to see the price that has the most X's, or you can also look at the table over here. What price? So was it $11, $12, $13, $14, $15, $16? Fill that in. How many shirts in all were sold? In all. Remember, we're totaling up all of the X's that you're going to be drawing here. Number 4, how many shirts were sold for $13 or more? So when we're talking about 13 or more, you need to count in how many shirts were sold for $13, how many shirts were sold for $14, how many shirts were sold for $15, and how many shirts were sold for $16. You're going to have to find the total of those 4 numbers. Use the line plot above for 5 and 6. Were more shirts sold for less than $13 or more than $13? Explain. So, up here for more than $13 or less than $13. So, for more than $13, I have 4 were sold for 14, 0 for 15, and 2 for 16. So I would take 4 plus 0 plus 2. So do I really need to add in that 0? No. So for more than $13, I have 4 plus 2, which equals, 4 plus 2, my brain was already at the answer, which equals 6. Now, shirts sold for less than $13. So for less than $13, I have 1 shirt sold for 11 and 4 shirts sold for 12. So less than 13, I would have 1 plus 4, which equals 5. So were more shirts sold for more than $13, or were more shirts sold for less than $13? As we could see here, 6 is greater than 5. So more were sold for more than $13. I know I don't really have a lot of space here. More than 13. I'm just going to circle that because that's my answer. Is there any price for which there are no data? Explain. So, no data means there are no X's on the table. If I come over here